in the working state method, we have find that we are providing sufficient safety and serviceability since that area is coming. In the working state method, we observe that area is coming more, and for that same reasons we are able to provide sufficient safety and the serviceability, but it was not economical, and that lead to the ultimate load method. In the ultimate load method, what we observe, though we are able to provide sufficient safety, but serviceability criteria was ignored. We are not able to fulfill the serviceability criteria since the area was coming low, cross sectional area was coming low. We are basically compromising with the serviceability criteria. Now, to overcome the limitations of working state method, which was not economical, and also overcome the limitations of ultimate load method, in which we have ignored the serviceability criteria, the limit state method come to the pictures. Limit state method, what it do? Limit state method ensure the probability of any limit state being reached is acceptably low. So it is saying that we will apply some limit on the stress, and also we apply some limit to the load, and will ensure that during your operation conditions or during the lifespan of the structures, that the structure will not experience the stress which was allowed, up to which it was allowed, neither load also will reach which was for which it was designed. Okay, so in that, so here there we will find that we are allowing up to certain level of stress in the limit state method, and also we are enhancing the load by applying some factor of safety, and probability of reaching that allowable stress in the limit state method is low, as well as probability of reaching the factor load for which it was designed is also low. And this factor of safety basically you can find in the IS code. IS code recommended it, and IS code also obtain it through proper reliability analysis. It is not like that somebody give you some factor of safety and you are applying it. For that reasons, for that factor of safety, IS code is doing the job for you. It is conducting proper reliability analysis to have factor of safety for the stress as well as for the loading conditions. So here we have learned that we can use limit state method, because limit state method is considering both safety and the serviceability criteria for the design purpose, and at the same time it is also economical. So whatever the was there in the working state method that which was not economical, that also we are overcoming. So whatever the demerit was there in the working state method and the ultimate load method, both we are overcoming by using the limit state method. At the same time, you are also ensuring the safety and the serviceability criteria. Though it cannot give you guarantee that structure will not fail, but the probability of the failure will be low. And for the same reason, IS code is doing the statistical analysis, some reliability analysis for you to recommend the factor of safety for the loading or the stress conditions, and you can use that load factor of safety for your design purpose. Limit state method basically based on two criteria: limit state of safety, which is also known as ultimate limit state, and the limit state of serviceability. First we will try to learn what is the limit state of safety, and then we will try to learn what is the limit state of serviceability. Limit state of safety, which also is known as ultimate limit state, deals with the partial and the complete failure or the collapse of the structure under the service load. Okay, basically it is saying that it is dealing with the failure of the structures, either partial failure or complete failure of the structures for the load for which it was designed. The failure or partial failure or complete failure may occur for the following reasons, in the following form: that it is exceeding the load bearing capacity, structure may overturn, it is exceeding the load bearing capacity, or structure is overturned, there can be slide if the boundary condition is not proper, there can be buckling, fatigue, fracture. So what limit state method is ensuring? Limit state method ensures that neither any part nor whole structure will collapse or become unstable under the any combination of loading for which it was designed in its lifespan. So all the structures should have one lifespan, and during the lifespan, neither any part nor the whole structure will collapse if we design as per our limit state method. Limit state method also need to take care about the abnormal but possible overload such as earthquake load, extreme wind load such as cyclone. All the things also need to take care in the limit state method. Basically, limit state method will give you the safety against the strength, against the stability, against the integrity of the structures. Integrity in the means that there will not be any partial failure. All the structures, the different component of the structure will intact. There will not be any partial failure. Stability means it will not overturn or there will not be slides. And strain is basically it will not fail due to the failure of the material, either concrete or steel. So basically, limit state method based on two things. One is the limit state of safety, or you can say limit state of safety, or ultimate limit state, or limit state of serviceability. In the limit state of safety, you are ensuring the safety against the strain or failure on the strain of the material, stability, and the integrity of the structures. Now we will try to learn what is the limit state of serviceability means. Limit state of serviceability is related to the satisfactory performance under the service load. Satisfactory performance in the sense it is satisfactory performance in the sense the structure must ensure that the occupant will not feel discomfort under the service load. That means for which that structure is designed, in that load the occupants should not feel discomfort. So let me explain the first term. There should not be excessive deflection on the structure. Suppose we have designed one floor like this, and the occupant try to work like this. So see here, the structure is not fail, but what happen, the structure basically you will feel the structure will undergo excessive deflection. Here you can see this excessive deflections. Okay, though the floor does not fail, but there is excessive deflections. Okay, if you design like that, in that case the structure will have excessive deflection and the occupant will not feel the comfort. Okay, there will be discomfort for the occupant also. So you should not design like that. So structures must ensure that there is no excessive deflections. Another thing is that cracking. There should be excessive cracking also. So what happens if the crack is there and crack is visible crack? So what happens? Whoever the occupant is there, they will not feel safe. They will feel very discomfort there. Okay, they may feel that structure may collapse because they are not the designer. Whenever they will see the crack, they feel that structure may fall. Though there is reinforcement, the structure may not fail, the structure may not collapse, but the occupant will feel discomfort. Another thing is that designing in such a way that there is excessive vibrations. In that case, what will happen? The occupant will not feel the comfort. Suppose you are constructing one building near the railway line. Okay, in that case, when the rail or when the train goes, that time you will find there can be excessive deflection in some building, and whoever occupant is there, they will not feel comfort during that time. So there should be excessive vibration. Suppose in a toll plaza you have constructed one building, so there is a two column in the side of the road, and at the top of that column you have make one floor, and the two column is connected by tie beam below the road. Now what happens when the vehicles, truck or heavy vehicle is to go, the tie beam is to go down. Okay, can go down, and due to that column also will try to come close. Okay, and due to this phenomena, what happens, there can be excessive vibration in the floor. It happened really in some places. I have observed in some places it happened due to that improper design. So in that case, that will excessive vibration. So structure should not be such that there is a excessive vibration. Suppose you are constructing building near your railway line in that case, or you are constructing some building where there is some chances of vibration. There is some chances. There is some chances that regular vibration load may come. In that case, you should take proper care. Apart from this case, in the serviceability conditions, the structure also need to satisfy the following conditions such as durability, impermeability, acoustics, and the thermal insulation. Impermeability means there should not be excessive crack. Okay, you will find that due to the shrinkage there can be internal crack, and if the internal crack join together, then there will be passage for the water leakage. So you should take care while designing. Okay, you should take care the shrinkage part also. Acoustic, whenever you are designing for classroom, you will find the many classroom that the classroom are not acoustically good. There will be some echo. Okay, in that case your voice will not be audible for the student. So you should have that proper care for the acoustic also. Thermal insulation should be there. And in case of durability, that you also should take care what is the exposure conditions. Okay, the structures in which environment you are constructing, you also should take care the durability part while designing in the limb state method. So what we have learned in the limb state method, basically there is two criteria. One is the limb state of safety, another criteria limb state of serviceability. In the safety criteria, we have learned that there should be strain, proper strain. Structure also should have integrity, should maintain integrity, and structure also should be stable. In the serviceability criteria, we have learned that while designing the structure, you should also take care that comfort of the occupant. And for the same reason, there should not be excessive deflections. There shouldn't be crack, much visible crack, vibration. There should be excessive vibrations. Thereafter, also you also should take care the impermeability, acoustic, and thermal insulations. So in case of permeability, you also should take proper care while you construct in the top floor or the floor near the bathroom or the washroom. So while constructing the top floor, if you pour more concrete at one time, okay, there will be high chance of the shrinkage crack. You should take proper care while casting the floor. There should be proper curing also, and you should also maintain water cement ratio, and also should use some admixtures to reduce the shrinkage. And while constructing the floor near the bathroom, you also take care that water flow, all the things. If there is water stagnant in that floor of the bathroom or the washroom, there will be high chance that the water will go down. There will be passage for that concrete, there will be passage for the water. Okay, and water will come down from the top floor to the below the bottom floor. Water will come down from the top surface to the bottom surface. Okay, that also need to take care.